Hello. For this one, I'm going to graph f of x equals sine x minus pi over 6. Here I've labeled my vertical axis as an f of x. I suppose you can label it as a y if you like. X-axis, the horizontal axis. So here, this is our amplitude is 1. So we're going to go up to a positive 1 and down to a negative 1. And our period is 2 pi over b. Since our b is 1, our period is going to be 2 pi. I showed it this way as opposed to the other ways I've done before because we're going to have a phase shift. This is going to shift the entire graph to the right, pi over 6 units. So let me first graph how this would look like a normal f of x equals sine of x. So if f of x equals sine of x, you're going to go through the origin. At pi over 2, you'll be at the 1, at pi, 0, and at 3 pi over 2, negative 1, and at 2 pi back up to the 1. Okay, so a regular sine graph would look like this, except we're shifting this entire graph over pi over 6 units. And that's why I spaced it as such, because this is 12 parts, so that pi over 6 units will be halfway between the two. So this is going to shift the graph. Let me go with that color. And when x is 0, we're looking at sine of negative pi over 6. So sine of negative pi over 6 is negative 1/2. So the graph that we want is going to look like that. The graph that we don't want, okay, so this is the graph of sine of x minus pi over 6. It's the same sine graph, it's just everything is shifted to the right, pi over 6 units. So the amplitude is going to be 1, because your A is 1. The period is going to be 2 pi, because the period is 2 pi over b. And the x-intercepts are going to be at pi over 6. Plus, so the x-intercepts will be pi over 6 plus 7 pi over 6 so this point here is 7 pi over 6. This to that point. This point here is 13 pi over 6, difference of 1 pi. We still have intervals happening every 1 pi. Okay, so when k is 1, we're good. When k is 2, we're not good. Oh, what was I thinking? what we have is pi over 6, and then pi over 6 plus 1 pi is 7 pi over 6, plus 1 pi is 13 pi over 6. So it's pi over 6 plus k pi. Okay. All right. F of x equals negative cosine x plus pi over 4. So our amplitude is going to be 1 because the lead coefficient is 1. The magnitude of the lead coefficient is 1. So this will go up to a positive 1, down to a negative 1. Okay. Our period is going to be 2 pi over b. So our period is 2 pi. Okay. Filling out the usual tick marks, we have pi over 2, pi, 3 pi over 2. And normally it would be graphed 0 comma 1, and then pi over 2 comma 0, and then pi comma negative 1. But this negative 1 is going to reflect it about the x-axis. So instead it'll go from 0, negative 1, up to pi over 2, 0, up to pi positive 1, and then back down to 3 pi over 2. That's just the shape of this because of that negative lead coefficient. But we're shifting everything to the left pi over 4 units. You want the additive inverses. And so this is going to start, again, they don't have a starting point, but it's going to start at there. No. This is the cosine function. Okay. And then the next point will be here. And then just had to think a little bit on this. So again, it's the cosine function, but it's reflective about the x-axis, and everything is shifted to the left pi over 4 units, pi over 4 radians. So the amplitude is going to be 1. Our period is 2 pi. And the x-intercepts are defined as pi over 4 plus k pi. Number 20. So I'm going to rewrite this as and the reason why I'm doing this is because this makes my phase shift easier for me to understand. When I distribute this, 2 times pi over 4 will give me pi over 2. Okay. So our amplitude is 1. Go up 1, negative 1. Our period is 2 pi over b, and our b is 2. So the period is going to be pi. That tells us this will be pi over 4, 2 pi over 4, 3 pi over 4, and if you like, this will be negative pi over 4. Our sine function normally would go these points here, but I'm shifting to the right pi over 4 units. So the graph will actually go and if you look, when x is pi over 4 minus pi over 4 is 0. 2 times 0 is 0. Sine of 0 is 0. So the amplitude is 1. Our period is pi, because our period is 2 pi divided by b. And the x-intercepts is at pi over 4, and then plus looks like pi over 2 minus pi over 2. So multiples of pi over 2. And this is where k is an integer. Okay. Cosine of 2x minus pi, let's rewrite this. This is the same thing as y equals cosine of 2 times x minus pi over 2. This is valid because 2 times pi over 2 is pi. Our period is equal to 2 pi over b. So our period is pi. Multiply that by 1/4 and we find we have pi over 4, 2 pi over 4, 3 pi over 4, and let's go with a negative pi over 4. Our amplitude is 1, so we're going to go up 1, negative 1. Our lead coefficient is positive, so this will be the regular cosine looking shape, if there is a regular cosine shape. Our phase shift, we're shifting everything to the right, pi over 2 units. Because when x is pi over 2, we have pi over 2 minus pi over 2 is 0. Cosine of 0 is 1. 1 times, no, I'm sorry. when x is pi over 2, pi over 2 minus pi over 2 is 0. 2 times 0 is 0. Cosine of 0 is 1. So that point is on the curve, and then finish it out. So our amplitude is 1. Our period is pi, and our x-intercept is defined as, we have pi over 4 plus this is k pi over 4. Sorry, that's pi over 2. Pi over 2, so we have k pi over 2. Thank you very much. Please go to tutoring.